At sunrise over the Gulf of Finland, a long-range UJ-26 Beaver skims the water toward Ust-Luga, the port Russia calls untouchable. A Russian patrol boat rips the quiet first, its 14.5mm gun flashing and an Igla-S leaping into the mist to swat one drone down. The rest split low and wide, riding wave height and cold air, because small composites beat big radars when seconds matter more than steel. This is not about how many missiles you own, but about who steals time at the edge and turns it into control at the target. Layer after layer wakes up, S-400 on the rim and Panzer inside the fence. Yet each shot burns money while the threat stays cheap. Electronic warfare floods the band, GPS tells lies, and fog bends light, while guidance hops channels and fights through the noise. The question is brutal and simple. If defense spends millions to stop what costs thousands, who runs out of options first? Tonight, the map of the Baltic energy chain hangs on speed, altitude, and clean handoffs in a very short kill chain. Stay with military force for clear maps, straight numbers, and field-level updates without noise. Each airframe used composites and smooth edges to keep radar cross-section low. Heat control mattered, so engines ran lean and stayed close to ambient temperature. Formation, spacing changed every minute to break pattern tracking and cue confusion. The lead unit carried the timing marks, and the rest slaved to silent checkpoints. Telemetry burst in short windows, then went dark to shrink the electronic footprint. Pilots followed the wave rhythm on instruments because fog and spray cut the view. This flight profile traded comfort for stealth, and stealth mattered more than ease. That set the stage for the first hard contact along the shipping lane. Sea pickets watched the surface with optics, radar, and listening gear at choke points. Patrol arcs overlapped near traffic corridors where targets must pass sooner or later. Lookouts scanned for thin silhouettes, while radar hunted for jitter in the clutter. Thermal scopes saw little through wet air, so crews leaned on Mark I eyeballs. When a track appeared, weapons crews shifted from search posture to engagement flow. Heavy machine guns built a tracer wall, forcing the drones to jink and lose time. Shoulder-launched missiles tried for tail chase shots where plume and heat were strongest. The engagement geometry was tight, since sea state and fog cut lock quality. Low altitude forced short decision loops, and short loops punished any slow handover. From there, the fight moved from seeing to shooting across a narrow band. The drones answered with altitude changes and lateral slides at fixed intervals. Wave-hugging flight pushed bullets high, while brief climbs reset seeker calculations. Lightweight helped, because quick nose inputs produced fast angle changes. Short radio bursts updated guidance only when geometry allowed safe transmission. When guns stitched the air, the drones rolled to hide profile and shrink time online. When missiles rose, they dove shallow to starve fins of airflow near the surface. These moves were not magic, yet timing made them look like it. Every saved second reduced exposure and stretched the defender's firing window thin. With the surface screen engaged, the column angled toward the coastal exclusion ring. Sea pickets do not decide campaigns, but they can drain tempo if left unchecked. Fuel burn climbs when paths bend, and battery margins shrink with each hard turn. Crews on the water face a human limit, since eyes tire and hands slow. Coverage also breaks where shipping lanes, buoys, and fog banks create blind alleys. That is why small targets that ride the wave often slip between patrol cones. Cost pressure adds up because constant alert burns hours, ammo, and maintenance. Even a single hit forces caution, and caution widens gaps for the next group. The aim at sea was never a knockout. It was to open a door inland. Once a lane exists, the rest of the kill chain can start to stack. With the sea screen strained, the burden shifted toward fixed batteries on the coast. At roughly 40 kilometers, the S-400 shifted from search to firm track and the picture tightened. The battery pushed energy into a focused beam, yet the returns flickered in sea clutter. Low flight squeezed the radar angle, and reflections off waves masked tiny shapes. Composite skins and smooth joints trimmed the radar cross-section to a fraction of a gull. Infrared signatures stayed weak in wet air, so thermal cues offered little help. Look-down geometry added noise, because the antenna saw water, spray, and targets together. Track files opened and closed as aspects changed, which hurt missile-quality solutions. Any delay in target confirmation cut the firing window, and raised miss-risk launch authority weighed the cost, since long-range shots were pricey and scarce. The unit faced a classic trade: shoot early with poor data, or wait and lose time. Waiting gave the drones room to slip lower, and slipping lower made tall missiles struggle. Under that pressure, the defense shifted focus toward the medium and point layers. This is where Russia moved to 9 M96 interceptors and the Panzer box to seal the approach. The 9 M96 brings high agility, and its gas-dynamic thrusters snap the nose across tight arcs. It tolerates violent turns without airflow, so near-surface dives do not kill control authority. Mid-course guidance updates from the battery feed smarter endgame math at short ranges. Pantsier batteries. Then close ranks, overlapping sectors like tiles on a roof. Operators build a box, so every path crosses at least one engagement zone. Doctrine favors shoot-look-shoot to save rounds and correct aim against weaving targets. Optical trackers and radar channels work together, while 30mm cannons fill a beaten volume. Gunners do not chase single dots. They cede airspace where geometry says the drones must pass. Fire units coordinate lanes to avoid fratricide and keep barrels cold enough for sustained bursts. This layered method trades glamour for reliability, and reliability is what stops leakers. Yet discipline under stress must hold, because wasteful salvos drain the whole belt within minutes. All of that structure tightens the net, but the net still has physics inside it. Composite bodies reflect less energy, so tracks bloom late and fade early near the surface. Low altitude compresses radar height lines, and multipathing over water distorts range gates. When drones crab across the beam, Doppler shift shrinks and velocity filters hesitate. Steep dives force long-range missiles to command hard pitch, and control fins can stall. That stall bleeds guidance, which is why near-target agility matters more than raw speed. The 9 M96 solves part of this problem with thrust vectoring and high-G endgame turns. Even so, short baselines and fog can starve electro-optical trackers of clean contrast. Pantsier can switch to guns, but guns demand time online that small targets deny. Every jink alters intercept math, and each roll trims the silhouette a tracker can hold. Kill probability rises in bursts, then falls as clutter and aspect flip the picture again. The defense still hits, yet it pays in rounds, tubes, and crew fatigue for every success. The exchange rate favors the attacker when cheap airframes force expensive choices under a clock. That is why the battle does not end at the fence. It pivots into the spectrum. With fixed batteries engaged and lanes contested, the next fight is over guidance and the airwaves. The electronic battle started when Russian stations swept the air for control links. Receivers scanned wide bands, paused on peaks, and built a map of live channels. Operators used a sweep and dwell rhythm to catch brief bursts and short telemetry pings. Once a pattern appeared, Jammers shifted power to a narrow cone for higher pressure. Power levels rose in steps, since too much spill risks friendly interference and blind spots. The goal was simple, because breaking the link forces guidance errors and wasted time. This approach created noise walls that turned clean signals into clipped packets and lag. From there, the defense tried to hold the drones inside a shrinking corridor of silence. That corridor mattered, as control without feedback can drift into bad geometry quickly. Under that pressure, the attackers moved to harder-to-catch radio behavior and timing. The drones responded with frequency hopping that changed channels dozens of times a second. Hops followed a stored sequence, and only paired radios knew the shifting order. Short packets carried compressed updates, and long gaps kept the footprint small on receivers. Antennas used low side lobes to avoid leaks, while power stayed just above the noise link design aimed for survival, since resilience beats speed when every second is priced. When the spectrum grew too hot, guidance logic cut to autonomy to keep the track. Autonomy used pre-planned legs, altitude gates, and time marks to follow the intended route. Inertial sensors carried heading and speed, while baro and radar altimeters held height. The stack averaged inputs to smooth spikes, because rough data can bend a path. This logic favors predictability, yet predictability risks ambush if the map has changed. Russian crews answered with barrage jamming that filled whole bands with steady noise. Barrage trades precision for volume, and volume breaks many weak links at once. The price is high, since broad noise can mask friendlies and jam their own sensors. Even so, area denial on the spectrum forced the drones deeper into onboard logic. Autonomy then met its limits where reality was not the same as stored charts. New cranes, scaffolds, and temporary towers were not present in the original grid. Radar altimeters warned on height, but they could not see thin steel crossarms. IMU drift also adds error over distance, and small biases grow into real offsets. These factors caused minor course bends, and a few airframes clipped structures in fog. Spoofing added a second trap by broadcasting false positions near approach corridors. Spoofing works when receivers trust timing and phase from the fake transmitters. Trust falls when inertial truth disagrees. Yet split readings still slow decisions. Some drones chased ghosts and turned wide, while others lost seconds correcting lines. However, most frames stayed on the axis because layered navigation shared the burden. Inertial data held the skeleton, altimeters, guarded height, and timing marks framed legs. Combined, these checks let guidance ride through noise long enough to reach the coast. Cost calculus also shifted, since wide jamming burns. Generators, tubes, and crew hours. That burn rate matters, as sustained noise at scale drains defense while drones stay cheap. The outcome was mixed on the map, but clear on the ledger and the clock. A few losses came from spoofed cues and new obstacles, yet the main column endured. Endurance under pressure sets conditions for the close layer and the final gate. With guidance still intact and lanes reopened, the fight rolled toward fog, guns, and industrial risk. Thick fog turned the last kilometer into a blind fight where sensors lost edge. Moist air scattered infrared light, so thermal imagers saw weak shapes and soft contrast. Spray and low clouds cut optical range to a few hundred meters in many sectors. Look-down radars over water met multipath distortion, which bent range gates and angle cues. Defenders stopped chasing dots and started guarding lanes that math said drones must cross. They plotted suspect zones by wind, terrain, and likely approach bearings toward tank farms. Fire units aimed not at pictures but at coordinates, and they pulsed fire on timers. This area denial logic saved time, yet it also burned ammunition at a steady rate. Crews loaded belts in waves, rotated barrels, and counted seconds between bursts like a metronome. Every pause risked a gap, and every burst risked waste, which is a hard balance. That shift from tracking to zoning forced the battle closer to the ground and closer to steel. Low visibility pulled the curtain down, and close-range weapons stepped into the spotlight. Man-pads teams set ambush positions on roofs, masts, and catwalks near likely corridors. Gunners listened for prop noise in the mist and aimed for hot exhaust on passing tails. Short-range seekers needed clean angles, so crews waited for the nearest echo of heat. Some shots bit, yet many seekers lost lock as fog washed the temperature contrast away. Zu-23 and twin 30mm mounts built beaten volumes instead of narrow streams of fire. Crews painted cubes in space where routes converged, knowing anything inside might get torn. This tactic punished rigid flight lines, while rolling drones cut time inside those cubes. Barrel heat rose fast, so burst discipline decided whether the guns could stay in the game. Mi-8 helicopters added pressure with downwash that shoved light airframes toward hard edges. Rotor wash cleared small holes in the fog that briefly helped both sides see better. Pilots tried to herd targets toward walls, while door gunners stitched the openings with tracers. Every maneuver cost battery and altitude, and each loss narrowed the escape set for the next turn. Close-in fire removed the luxury of distance, and distance had been a shield all night. As ranges collapsed, the geometry of the plan itself became part of the fight. Industrial safety systems woke up the moment unidentified craft neared protected units. Valves opened to vent pressure, and flare stacks took load until thresholds were reached. Automatic logic favored prevention, so lines dumped gas to avoid catastrophic overpressure events. But venting made a new hazard, because cold hydrocarbons spread into a wide, invisible cloud. That cloud had a lower explosive limit, and wind shear-shaped pockets of dangerous mix. Ignition sources multiplied around a live port where metal scraped, engines idled, and rounds sparked. Water cannons tried to knock drones off course with hard jets that hit like clubs. Streams bent airframes and snapped props. Yet water could not quench thermite if it lit. Foam curtains shielded some assets, but foam hates wind, and fog made foam placement guesswork. Security cut power in sections to lower sparks, while operators isolated lines to protect the core. Each safety step bought minutes, and minutes decide outcomes when fire and gas are neighbors. If a warhead touched thin steel at a weak seam, heat could open a path in seconds. A breach would flash fuel into vapor, pressure would jump, and pipe racks could fail in series. This is how one hit can become many, because physics scales damage when systems are linked. Under that layered risk, defenders had to choose between heavy fire and accidental ignition. A hard volley could kill a drone, yet the same volley might light a cloud they could not see. Restraint. Lowered sparks but raised odds that a small target would slip through the last gate. Either way, cost rose by the minute, and the margin for error shrank with every shot. With fog still thick and safety systems straining, the final outcome moved to a single decision point. That point sat where steel, fuel, and timing meet, and it would define the meaning of the strike. One last airframe slipped through the net, struck the cold processing unit at low height, and turned a thin steel wall into a bright wound that bled heat. Thermite burned through the shell within seconds, superheating trapped liquids, and the pressure spike ripped nearby joints while alarms flooded the plant with warnings. Pipes buckled under thermal stress, valves slammed shut in cascades, and flare stacks took load until safety limits forced emergency vent lines to open wide. Gas expanded across catwalks and cable trays, invisible in the fog, while sparks from small arms and metal friction raise the chance of secondary ignition everywhere. Operators isolated blocks to stop a domino. Yet each cut created new flow paths that drove the fire triangle toward a dangerous balance of fuel and air. A local breach became a system event because linked vessels share heat and stress, and linked systems fail in groups when thresholds are crossed together. The strike did not need a massive blast to matter, since one precise hit forced a high-cost shutdown and a long list of repairs that cannot be rushed. This is why a single drone can reshape a week of operations. And that week is where logistics and revenue feel real pain before headlines catch up. From the plant outward, the impact moves through schedules, because disrupted units slow loading, and slow loading ripples into ship queues, insurance checks, and berth changes. Maintenance crews must replace seals, test sensors, certify welds, and run cold starts under strict rules, which means time is fixed by safety, not by desire. Stock on hand may cover small needs, but bespoke items demand fabrication windows, approvals, and transport that cannot be compressed by slogans or press notes. All of this sits on the ledger, where idle hours and diverted cargo create costs that add up faster than most people expect in a tight market. That leads to the core trade. Defenders spend millions on interceptors, helicopters, and constant jamming, while attackers spend thousands on airframes that force expensive choices under time pressure. High burn rates. Drain readiness because crews tire, barrels heat, missiles deplete, and generators gulp fuel. Yet the attacker can rotate cheap platforms and keep the rhythm. Ukraine will chase saturation effects with staggered waves, multi-axis routes, and smart timing that strains command posts while keeping the price per strike low across the board. The meaning of this last hit is simple yet sharp, because the side that turns seconds into shutdowns shapes the next map, which is where the conclusion begins. The rule is clear in infrastructure war, because the side that shortens the kill chain and uses terrain, weather, and spectrum wins at low cost. This strike shows how seconds and angles can shut a complex that walls and missiles could not fully guard. The strategic effect is deep, since hits on energy and logistics push protection bills up and stretch air defense and EW across a wider map. That strain opens gaps elsewhere and slows repair work, while shippers and insurers reprice routes in real time. Watch the next 48 to 72 hours for S-400. And Panzer moves around Ust-Luga. Stronger spoofing and jamming, AIS traffic shifts, repair tempo, and any repeat of multi-axis raids. If point defense thickens around critical units and safety loops harden, intercept cost may fall and uptime may rise. If Ukraine sustains staggered waves with clean timing, shutdowns may recur and pressure may climb across the Baltic chain. The balance now turns on who controls the short handoff from the sensor to strike under fog and stress. So here is the open question. Does the defender run out of money first, or does the attacker run out of drones? For clear maps, straight numbers, and field-level updates, like, share, and subscribe to Military Force.